Hi, I'm Redneck Junior, and also known as Redneck Professor's trusty sidekick.
Hello kiddos, Redneck Professor here, and you've met my trusty sidekick, Redneck Junior. Today we're going to do a little light duty DNA extraction. You know what DNA stands for?
Yes.
What?
It stands for the stuff that controls our cells.
It controls our cells, but what do the letters stand for, do you know?
Yeah.
Deoxyribonucleic acid. Can you say that?
Johnson, okay, I forgot.
Can you say that?
Johnson,
That, there you go. Exactly. Deoxyribonucleic acid. We're going to extract some of that from
strawberries.
some strawberries.
I already said that. You don't need to say that, Redneck Professor.
Alright, well, why don't you do the experiment then? Okay. First thing we want to do is get some strawberries. About 3 good sized strawberries. I don't want to use that one because, see, it's got mold on it, right? We don't want... Mold and fungus also has DNA. And so we don't want to contaminate our strawberry DNA with mold or fungus DNA. So I've selected 3 strawberries here.
Put them in the bag.
And I want to cut the tops off of them. And of course, you don't want to do this by yourself, do you?
No.
No, you want to get your parents to help you cut the tops off of the strawberries. And if your parents don't want to help you cut the tops off strawberries, they ain't very good parents. So I want to cut the strawberries up a little bit.
Yeah.
Put them in that there Ziploc bag.
Can I smash that?
Let's not get ahead of ourselves. And cut the top off of this one here. The little strawberry says, no, don't cut me, don't cut me.
Honey.
Cut this guy up. Put him in the bag.
Then smash it.
And what I want to do is close up the bag just a little bit. What, are we working in a TB ward over here? Let the air out of it. Hey, don't make me angry.
Okay.
You wouldn't like me when I'm angry. You know what happens when I get angry?
No.
Oh, smash! So we want to smash the bag. Smash it for 2 minutes. So we got our timer set. I'm going to go watch the strawberry ickiness off my hands. You entertain the crowd.
Okay, hi, I'm just smashing the strawberries alone. And Redneck Professor is washing his hands from that ickiness from the strawberries. Here. Dad, look how much you smashed them.
Well, congratulations on smashing.
I'll watch him. Dad, superheroes were created with science except for Iron Man. He made a suit by himself.
Iron Man is lame.
How is he lame?
Absolutely lame.
Why is he lame?
If he didn't have his suit, he wouldn't be nothing. Who would he be without his suit? Iron Man. Iron Man.
Yeah.
You got it good and smashed up? Has the timer gone off yet?
No.
We gotta wait for the timer. Everything rests upon accurate measurements. Science rests on accurate measurements. And one of the measurements that you have to be accurate and precise with is timing. So that's why I have our handy dandy timer. I don't think it's been calibrated though.
What's calibrated mean?
It means somebody looked at it and said that it was good and it was okay and it was exact and what have you. I don't think this one's been calibrated. You about done?
I think I was ready to turn all along, but I still have some more.
Are you about done?
Yes.
Yes. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There you go. Alright, now we need to set it again for 1 minute. So we have puree. We have this nice little strawberry puree here in the bottom of the bag. Now we want to add what we call in science a reagent.
Hmm?
You know what a reagent is? Can you say that?
Reagent.
No, can you say that? There you go, that. A reagent is any liquid that we use in science, for the most part. That's a simplified definition. Water could be a reagent as long as we're using it in the lab.
Soap? Soap is a type of
Yeah, liquid soap could be a reagent. It could be part of a reagent. But pretty much liquids that we use in the lab, we refer to them as reagents. You want to know why?
Why?
Liquid doesn't sound sciencey enough. Now, this reagent is made out of 3 secret ingredients. Do you know what those 3
Soap
secret
and
ingredients
water.
are?
Soap, water, and bubbles.
Soap, water, and bubbles. Dish detergent, salt, and water. Now,
Reagent.
this reagent is also a lysate. You know what a lysate is?
No.
A lysate, lyse is a fancy word for cells going blah. We want our cells to go blah, right? Because where's the DNA?
Inside.
Inside the cell. We got to get the DNA out of the cell, so in order to get the DNA out of the cell, it's got to go blah, right? When cells go blah, we call that lysing. And the dish detergent actually works as a lysate. Makes the cells go blah, okay?
It kills the cells.
It does kill them, unfortunately. Bless your hearts. So I want to pour up, actually I want to spill some of this first, right? You want to know why I spill some first?
Why?
I don't have to worry about it later on. I've already spilled some, so later on I don't have to spill any, right? Got that part out of the way.
Yeah.
So I want to pour up about 50 mils.
50 mils, which is the top.
You know how many mils are in 50 mils?
No.
50. You know what a meal is?
50 mils. 50 mils.
You know what a mill is?
No.
That's where they grind up flour.
Hmm.
Oh, that's a mill. Mill is a word that we use. It's short for milliliter. Milliliter. Now, kiddos, if you don't have one of these fancy graduated cylinders at home, you can get them on Amazon for pretty cheap. Ask your parents to do it for you, and if they don't do it for you...
They're not very good parents.
Good parents support science, right? Redneck Jr.?
Yeah.
All right, so I want to pour about 50... Ugh. Smell that.
Well,
Okay.
it smells kind of like trash.
It smells kind of like trashy strawberries. So I want to pour about 50 mils of this reagent into there. And that's dirty, so I don't want to use that anymore. Now I want to close the bag back up. Let as much of the air out as I can. That's why I'm wearing my lab coat, so I don't spill strawberry guts all over me. And then what are we going to do? Don't make me angry. You wouldn't like me if I'm angry. You know what happens when I get angry?
Yeah.
Hulk smash! You want to smash it some more?
Yeah.
Yeah? Alright, for 1 minute. 1 whole minute. While we're doing that, I'm going to clean up my mess.
Hot mess. You didn't make any mess.
I spilled some already.
Oh, yeah, right.
Hulk smash!
I smashed my screen. It was science.
Hulk smash. Yeah, he was radiation, wasn't it?
Yeah.
Radiation.
He got mad too much,
On
so
the
he
computer.
He got mad too much, so he turned into Hulk smash.
This is another reagent
Yeah,
we're going to use. Uh-oh. I may not have sealed it up properly. Uh-oh. Go wash it off.
I do not want to lick this off.
Ah, got strawberry goo all over everything. All right, I'm just going to really carefully because I'm not sure where the... I think it's got a hole, actually. I don't think it's... Anyway, we got us a little scientific debacle. Fortunately, saved by the bell.
I need to turn things off. Thank you.
All right, we're done with the timer for now. Can I have that back because I was actually using it? All right. Now, what we want to do is we want to strain our DNA puree, our strawberry puree. So I've got a funnel here. I've lined it with some cheesecloth and I've stuck it into a drinking glass. You ever seen a glass drink? Why do they call them drinking glasses then? They don't drink.
Because people drink alcohol.
Oh, because people. Why don't they call them drinking people? Glasses. People drinking glasses.
That's making sense.
Okay.
That's why.
So I want to. You know what the fancy scientific word for pour is?
I know.
Decant. Decant. Actually, I think decant is French for somebody who can't do something. Oh yes, that's Charles decant. Anyway, I want to decant my puree into my filter.
It's not even dropping.
It's dropping very slowly. This might take some time.
It takes 200.
That's okay though. We got another reagent we can talk about.
Yay! I didn't pour everything.
That's okay. We've already made enough of a mess with the strawberry puree. All right, so while that is filtering.
Okay, now I'm not in the shot here.
We might end up needing a smaller vessel.
What's a vessel?
Or I might have. That's going to take some time. It's going to take it. All right.
Okay, can I get through here because I'm kind of not in the shot with that glass out of the way.
Sorry.
What are you doing, Dad? Oh yeah, sorry. I was just checking what my dad, redneck professor, is doing. Sorry for the pause.
It helps to be prepared.
Yeah.
Be prepared. All right.
Yeah, more like that.
So we have another reagent. While this is very slowly filtering, we have another reagent we can talk about. This, feel it.
It's cold.
Is it cold? Why is it cold?
Because you put it in the freezer for 3 days.
Yeah. This is isopropanol, also known as isopropyl alcohol. And some really fancy highfalutin folk call it rubbing alcohol. Can you say that?
Rubbing alcohol.
No, can you say that?
That.
No, there you go. All right, so I've chilled this. You only need to chill it for about 20 minutes. It's not going to freeze because it's just in the nature of alcohol not to freeze. And I just want to pour a little bit of it out here.
Oh, I thought you were going to pour all of it.
No, I don't need a whole lot because we're not gonna let this stuff run out too much longer.
Why?
Well, it's just getting boring on the video. I'm sure our viewers would rather go ahead and see the magic and fireworks than watch this stuff filter boringly. Look how drip, drip. All right, so I'm going to take this and put it over here. And now, what's the fancy word for pouring?
Yeah.
Decant.
Decant.
And I'm just going to get a real small glass here. Okay? And I actually want to pour a little bit of my isopropanol in here for now, just for fun. Alright, so what I want to do is decant what's left of my strawberry puree, my filtrate. You know what happens when stuff goes through a filter? You know what we call it?
No.
We call it a filtrate, because it's been filtered.
Yeah.
Alright, now this is the really tricky part. Okay? What I want to do is very carefully pour my chilled isopropanol onto the top of my filtrate.
Oh.
Okay? It should form a layer.
What's a layer?
A layer. Okay? So what I want to do is I just want to tilt both glasses and very carefully pour this on.
Oh, so that's a full. Looks kind of pretty, doesn't it?
It does.
How long is that going to stay?
It's going to stay just like that. Okay, so you see, I've got two layers. Right, I've got a very dark layer at the bottom. I've got a clear layer on top. Do you see what's in the clear layer?
Yeah.
What does it look like?
DNA.
What does it look like?
Puffy clouds.
Puffy clouds. Okay, let's see This might not show up on the camera very well, but you can see in the clear layer there, it looks like what wispy, stringy, puffy clouds. And that is our strawberry DNA.
Yeah.
And I want to try very carefully to isolate some of it. You know what this is called?
No.
Micropipetter. If I can't do it with this, I might be able to get it with this Pasteur pipetter. I don't know. But I'm going to try it with this first because I love these things. Oh, you look at, we got it goopy. See the goopy?
What's a goopy?
You see that goopy on the end?
Yeah.
That's our DNA.
It doesn't look like DNA.
This isn't going to layer out like I wanted it to. So now we have isolated some of our strawberry DNA. And it's down in the bottom. See if I can get a little more. Just want a little more.
Dad.
Problem is if I get too close, I pick up the strawberry puree and I don't want it. There we go.
Now you got the DNA.
That time I got some good DNA.
Dad, what's a goopy?
Something that's goopy.
What's a goopy mean?
Now you can't see that because it's all frosty, but you see it floating in there, right? That little floaty.
No.
Oh well, you know what?
What?
It's sunk down to the bottom.
Oh no.
If you're not part of the solution, you're part of the precipitate.
Okay, now this is the end of the videos. Bye bye, viewers.